Let us see now the potassium dichromate. The formula is K2Cr2O7, which is the most important oxyanion of this transition elements. Let us first discuss its preparation. It's prepared from ore called ferrochrome. The formula is FeCr2O4. Now it involves 3 steps. First, the crushed and the powdered ore is heated with sodium carbonate in presence of oxygen, where it gives sodium chromate, yellow colored sodium chromate. Fe gets oxidized to ferric oxide and we get CO2. So it's almost as 4 balanced like this. So we get yellow colored sodium chromate. This yellow colored sodium chromate is then oxidized to sodium dichromate, orange colored sodium dichromate, by treating with sulfuric acid. Now this sodium dichromate is separated out and is then treated with, in the third step, saturated solution of KCl to obtain K2Cr2O7 plus NaCl. So this is how we prepare potassium dichromate indirectly through sodium dichromate because of the lesser solubility of the sodium dichromate ion, due to which it can easily separate it out from the reaction mixture. So this is how potassium dichromate is prepared. Now let us study the properties of the potassium dichromate. See, it's an orange red colored or brick red colored crystalline solid, and when it is actually, this dichromate ion is exposed to the basic medium, it changes to yellow colored chromate ion. Now this yellow colored chromate ion solution, when treated with acid like sulfuric acid, it again changes to orange colored dichromate ion. So these two reactions shows that the dichromate, orange colored dichromate, is interconvertible with yellow colored chromate ion. The moment we make the medium basic, it changes to yellow colored chromate, and the moment we changes the medium to acidic back, it again gets back to the orange colored dichromate ion. So it's mainly because of the pH change. That's why we call this reaction to be an pH effect. Now this clearly tells us that the chromate and the dichromate can be interconverted, and now let us see the structures of these chromate and dichromate ion. The CrO4 2- chromate ion is having what? Tetrahedral arrangement with all 4 CrO bonds equal in length. The reason being because of the resonance involved in this. Actually, it is like this, that the 2 oxygens are having pi bonds with the chromate, and the rest of the 2 are having negative charges. So we put it like this, they are perfectly tetrahedral. Whereas in dichromate ion Cr2O7 2-, what we find is 2 of such units are joined to each other like this. So we put it like this, 2-, and this angle where these 2 units are joined to each other is at an angle of 126 degree. So these are the structures of chromate and dichromate ion, in which the chromium in both these cases are actually sp3 tetrahedral in structure.